Hi, today's section is 8.4, Radical Notation for Nth Roots. And I've kind of already jumped into this a couple days now, yesterday's notes on 8.3 and one time back in chapter 7, because this is how it's just normally done and what I'm used to. The stuff in green I wouldn't write, just trying to make a point. But if you had something like this, and they said, well, that's x to what power? You'd say it's x to the third power. Kind of a no-brainer there. If we just have an x, the question is, well, that's x to what power? Well, be x to the first. And the reason I want to make that point is that when you have a x to the first power, you don't have to write the 1. It's actually not considered simplified with a 1 there. And the reason I say that is if we're going to have something like this, our radical notation, in today's section we're going to start doing things like this. This here would be the cubed root of x. That's the same as x to the 1/3 power, is how our book taught it in the last chapter. Well, we have this 3 kind of here on the ledge of the radical. This here is assumed to be a square root. That's the same as x to the 1/2 power. But when it's a 2, we don't write it. Just like when we have an x to the first, we don't put the number in. And that's the point I'm trying to make there. But I digress. Let's jump into today's notes. So let's say if we wanted to talk about like the 4th root of x or something like that, what we had done before would be to say, well, that's x to the 1/4. And what we're doing today then is that we'll write this as though it's the 4th root of x this way. And if we were to actually go through and do this with, maybe I should say the 4th root of x, the 4th root of x. We could go through and do that with a couple numbers. If we had, say, the 4th root of 81, that's the same then as saying 81 to the 1/4, is how we did it in the last chapter. But it's really saying what number to the 4th power equals 81. That's going to end up being a 3. Two ways to punch that into your calculator. One way is going to be to do 81 to the 1/4. With the older operating systems, you need to have parentheses. Another way is to use this radical notation, and this is how you punch it in on a Texas Instruments calculator. One way is to just treat it the way we used to do it. You could say 81, then if you do your exponent key, with the newer operating system where you see right here it actually gives you a superscript up above, you can just do the 1/4. And then you do your right arrow if you want to get out of that and type something else, but that'll give you the answer. With the older operating system, unfortunately I can't really show you here, but if you type in 81 to the 1/4 and it doesn't jump up and give you that superscript right there, then what you'd have to do is you'd have to put it in parentheses and do 1/4 that way, or you could do the decimal 81 exponent 0.25. What it should look like would be something, let's see if I can get my pen to work. It should look like this, or it'd be right here. So 81 caret parenthesis 1 divided by 4 parenthesis. So that's what it would have to look like with the older operating system. We'll get rid of that. Then, alright, the other way to type it in, you just get rid of all of this, clear out my key press history. Now with a cubed root there's a little bit of a shortcut you can do, but for a 4th root this will work for any root number, 4th root, 7th root, millionth root. If you press your 4 for the 4th root, then go over here to your math key. Now we want to pick number 5 right there. And now we could type in our 81. I could just hit enter. If you want to get out of the radical because you have something else to type in, you can press your right arrow to get out of that. But that's how it would look with this operating system. If you go with the older operating system, it would look this way when you type it in. It would give you a 4, and then an x, radical, and then 81. Actually, I think there's a parenthesis in there too. And then if that's the only thing you're typing in, you could just hit enter at this point, or you could end the parentheses and hit enter. I have 2 more for calculator practice. I'm going to write them down and hopefully you punch them in yourself. But the 5th root of 1024, you might want to not even write it. Just grab your calculator, go through and punch that in, and the cubed root of 729. If you notice, I think if you do your math button, then I think it's option 3 could just give you right to the cube root. You wouldn't have to type in the 3 first. But if you punch both of those in and get the right answers, you should have a 4 and a 9 for those. All right, moving on. If we have, say, 8 to the 1/3, we could write that as the cube root of 8. The question then is, what do you do if it's not a simple fraction like this? You get something a little bit more complex, like an 8 to the 2/3. And the question says, well, write that in radical notation. So we need to have some sort of a radical with our 8, and it would make sense that the 3 would still go there. The 3 is still the root. The question is, what do you do with the 2? Well, the 2 is really like a exponent. It's like a power. So we need to square the 8. So usually it's written on the inside like this. I suppose you could take that 2 and also slide it here to the outside, but normally that's the way you'll see it done. Another one like that, just write it over here. If we had 128 to the 4/7, if I could get you to go through and write that in radical notation. So 128 to the 4/7. Hopefully you're done by now. So it'd be the 7th root of 128 to the 4th power. So that'd be the way it would be written. So now let's go through and kind of summarize then. I'll put it in red because here's kind of the rule, that if we have the nth root of x to the m, so the nth root of x to the m power, that there equals x to the m over n, because the root is always the denominator. This is really the end of the chapter 7 stuff. And that's going to be where first of all, x has to be greater than 0. M and n are going to be natural numbers. That you're not going to have like a 0.2 over 7 or something like that. So they're going to be 1, 2, 3, 4, 5, 6, your counting numbers. And the last thing is that n is going to be greater than or equal to 2. It'll be like a square root, a cube root, 4th root, 5th root, so on. The very last thing I wanted to hit in this section is going to be this. If we have, say, the square root of x, and it says write that as a single radical. It looks bad, it's really not. That if you have this, I'm going to put the 2's in, just so we know that they're both square roots. That's really not proper, but if we take and change this to an exponent, we don't know how to combine radicals, but we're good at combining exponents. At least hopefully we are after surviving chapter 7. So if we have x to the 1/2, that's going to be this inner radical there, because square root of x is x to the 1/2 power. This outer radical then is going to be another 1/2 power. And if you think back to chapter 7, well, now how do you combine your two exponents? You multiply. And multiplying fractions is the same as just extending the fraction line. Multiply the numerators, multiply the denominators. So 1 times 1 gives us 1. 2 times 2 gives us 4. So the x to the 1/4 power. Well, if it's saying write it as a single radical, then x to the 1/4 is the 4th root of x. And I perhaps picked a bad example, because here if I have my two 2's, well, if you look at the 2's, you combine them and you get a 4. Well, do you add them to get 4, or do you multiply them to get 4? But really what you're doing is you're multiplying here. You can see it when you do the exponents. So if you get something, doesn't matter really how awful it looks. If you have the 5th root of the cubed root of the square root of x, it's saying write that as a single radical. You could look at it as though there's a 2 there. Well, what do you do to the 5, the 3, and the 2? You multiply them all. So 5 times 3 is 15, times 2 gives you 30. So that is going to equal the 30th root of x. That's all I have for the section.